Hi friends, welcome to our YouTube channel Maths Olympiad by Subbarao. Today our topic is Cramer's rule. Cramer's rule used in to solve the system of unknown linear equations to bring it to the form of matrix. So that's why this Cramer's rule is known as the determinant method, provided that determinant of matrix is not equal to 0. Determinant of matrix is not equal to 0. Next, in this video you will watch only to solve the 2 variable linear equation and 3 variable linear equation in Cramer's method. Let a1x plus b1y is equal to c1. a2x plus b2y is equal to c2. This is the 2 variable linear equation. Next, first we will convert it to the form of matrix. As per the Cramer's rule, matrix A is the coefficient of variables. That is, coefficient of variable means x coefficient a1, here x coefficient a2, here y coefficient b1, y coefficient b2. That is, matrix A is equal to a1 b1, a2 b2, a1 b1, a2 b2. Next, x is equal to column matrix of unknown. Here unknown means this is variables x and y. X is equal to unknown matrix, column matrix x, y. Next, B is the column matrix of constant. B is the column matrix of constant, that is C1, C2. B is equal to C1, C2. If this linear equation we rewrite it to the form of matrix, that is A equal to a1 b1, a2 b2, x is equal to column xy matrix, b is equal to this constant c1, c2. A is the coefficient of matrix, x is the unknown column matrix, b is the constant column matrix. If such is the case, to solve the x and y values, in this Cramer's rule formula, A into x is equal to B. A into x is equal to B. So that means A matrix into x matrix is equal to B matrix. A matrix into x matrix is equal to B matrix. So that means coefficient matrix into unknown matrix is equal to constant matrix. So after multiplication and simplification, it is brought to the x is equal to determinant of ax by determinant of a. Determinant of ax by determinant of a. Similarly, y is equal to determinant of ay by determinant of a. Determinant of ay by determinant of a. If it is a 3 variable linear equation, then z is equal to determinant of az by determinant of a. Determinant of az by determinant of a. Next, to solve the system of either second order or third order linear equation, as per this Cramer's rule, ax is equal to b. What is a? A is the coefficient of matrix. That is a1 b1, a2 b2. A is equal to a1 b1, a2 b2. Next, x is the column matrix of unknown. Column matrix of unknown means x and y. That is x is equal to xy. Then b is the column matrix of constant. Column matrix of constant means that is c1, c2. With this Cramer's rule, to solve the x value and y value, x is equal to determinant of Ax by determinant of A, and y is equal to determinant of Ay by determinant of A, and so on. Next, A1, B1, A2, B2. So this is the matrix. How to solve it? Simply to cross multiply, provided first main diagonal, then other diagonal. First multiplication is main diagonal, then cross multiplication is other diagonal. That is, determinant of A is equal to A1 B2 minus A2 B1. This is the determinant of A. Next, diagonal multiplication A1 B2 minus B1 A2. So this is the determinant of second order matrix. So for this second order matrix, determinant of A is equal to A1 B2 minus A2 B1. So that means we know the determinant of A now. Next, what about AX? Matrix AX. So this is matrix A. Matrix AX is nothing but replacing the X coefficient with B column matrix. Replacing the X coefficient column with B column matrix. Next, matrix AX is equal to, instead of A1 A2, simply you can replace the C1 C2. C1 C2. This is as it is, B1 B2. Next, A matrix is equal to A1 B1 A2 B2. AX is equal to C1 B1 C2 B2. So that means AX matrix is obtained by replacing the first column with column B. Similarly, matrix AY. Matrix AY. Matrix AY obtained, replaced by the second column with B matrix. Why? Because second column means it is Y coefficient. Here, as usual, A1, A2, where column is replacing with B, C1, C2. Matrix AY is obtained by replacing the second column with column B, that is constant values C1, C2. Next, now you know very well that determinant of this matrix, this also, after solving the determinant, therefore X is equal to determinant of AX by determinant of A, and Y is equal to determinant of AY by determinant of A. Okay friends, we will solve the one example problem of two variable linear equation. 2x minus y is equal to 5 and x plus y is equal to 4. This is the two variable linear equations. With this two variable linear equation, we bring it to the form of matrix. How to bring it? A is the coefficients of linear equations. Matrix A is equal to coefficients of linear equation. 2 minus 1. 1, 1. Next, X is the column matrix of unknown. That is XY. X is equal to XY. Then B is the column matrix of constant. Constant means 5, 4. To solve this equation with Cramer's rule formula, x is equal to determinant of x by determinant of a and y is equal to determinant of y by determinant of a. First you find the determinant of a, determinant of ax, determinant of ay. Automatically you can solve the x and y values. Determinant of a is equal to determinant of a. Cross multiply it. 2 into 1 minus of minus 1 into 1, that is equal to 2 ones are 2, minus into minus plus 1 into 1 1, that is equal to 2 plus 1 3. So determinant of a is equal to 3. Next, to solve this through Cramer's rule, this determinant is not equal to 0, then only it is possible. So that means this determinant of a 3 is not equal to 0. Determinant of a is not equal to 0. Then only it is possible. Now you can proceed further. Next, matrix AX. Matrix AX. Matrix AX means simply you can replace the x coefficient column with column B. X coefficient column is 2, 1. Replace with column B. 5, 4. This is as usual. Minus 1, 1. Then determinant of AX is equal to cross multiplication. 5 into 1 minus 1 into 4. Minus 1 into 4. That is equal to 5 ones are 5. Minus into minus plus 1 fours are 4. That is equal to 9. So determinant of AX is equal to 9. Determinant of AX is equal to 9. Next, matrix AY. Matrix AY means simply we can replace the second column with B column matrix. Simply you can replace the second column with B column. Matrix AY, first column, that is x coefficients are as it is. Then comes to second column, that is y coefficients. Replace with B, that is 5, 4. Then determinant AY is equal to, as usual, cross multiply it. 2 into 4 minus 5 into 1, that is equal to 2 fours are 8, 5 ones are 5. 8 minus 5, that is equal to 3. So therefore determinant of AY is equal to 3. Determinant of AY is equal to 3. Now you can find the x value and y value. So therefore x is equal to determinant of ax by determinant of a, that is equal to determinant of ax, how much? 9, by determinant of a, 3. 3 ones are 3 threes are, that is equal to 3. And y is equal to determinant of ay by determinant of a, that is equal to determinant of ay, how much? 3, by determinant of a, 3. 3 ones are 3 ones are, that is equal to 1. So therefore x is equal to 3 and y is equal to 1. Therefore x is equal to 3 and y is equal to 1. These are the values. If you want to, simply you can substitute the values here and check it. 3 plus 1, 4. X plus y, 3 plus 1 is equal to 4. Okay friends, thank you for watching this video. If you are interested, kindly like, subscribe, share your friends group, ask them to subscribe such more practice videos. Thank you very much.